Welcome back, everyone. This is the 10th annual virtual residency workshop. Uh, it's Tuesday, June 25th, 2024. I'm your host, Henry Neiman, and I'd like to welcome you back. This is our Tuesday afternoon session. This is a panel, How to Learn and How to Teach Research Computing Resources. Our moderator is Jose Hernandez from Florida State University. And Jose, I'm going to turn it over to you to introduce the panel or have them introduce themselves. So go ahead and get started.
Sounds great. Thank you, Henry. Everybody can hear me okay? All good? Okay. Sounds good. So yeah, welcome to our panel. So now we'll just be doing intros, a little bit about me. I work at Florida State University. I work at the Research Computing Center there. I'm the Digital Humanities Facilitator, and I'll be moderating your panel today. So if you have any questions, please pop them in the chat or feel free to raise your hand and we'll be counting on you for questions. Okay. So let's get started with the intros. Please go ahead, Eric, if you can take us away.
Great. Thanks, Jose. So I'm Eric Coulter. I'm currently the RCF team lead at the Georgia Tech Partnership for an Advanced Computing Environment. We call ourselves PACE for short. I've been part of this team for a little over a year now. I haven't been in the RCF side for very long, but before that, I've been involved in the community from the sort of the Exceed Access side, as helping people more on the system side of things, but doing what is effectively research computing facilitation for system administrators. It's complicated, but I'm happy to be here. I've really enjoyed all of the experiences I've had in the RCF world, and hope we'll have something to contribute. Let's see, I don't know who's up next. Let me look at my list. Nicholas Daines, you're up next.
Oh, all right. Hi, my name is Nicholas Daines. My official title is computational scientist at Colorado School of Mines. I will be in this position so it's going to be 4 years in August. My background is I did a bachelor's and a PhD in applied math. I actually got my PhD from Colorado School of Mines. I did research on the mines HPC clusters when I was a graduate student, and then graduated in 2019 and then worked in industry and then ended up back here. So that's the short version of the story. Uh, but primarily day to day is doing research facilitation with anyone who uses our on-site clusters, and more recently helping people work on other systems such as like Access. And I think that's all I have to say. I don't know who's next either. Michael Ennis.
Hi everyone. I'm Michael Ennis from Idaho State University. My position at Idaho State University is the High Performance Computing Research Solutions Architect, and I've been here at ISU in this role for just over 2 years now. And the main goal of my role is to grow the research computing department at my university through research facilitation, mainly for a supercomputer that was generously provided to us by the Idaho National Laboratory in sort of a joint collaboration with the three leading research institutions in my state. I think next is Amira.
Yes, thank you so much, Michael. Apologies for my voice. I'm a little bit sick, guys, today. I'm so happy to join you. Thank you for having me today. And I'm a computational scientist at University of Illinois at Chicago. I just joined 10 months ago. I was very happy to be a facilitator, which is a job that I discovered during my PhD when I got a lot of help from the supercomputing center that helped me finish my PhD and got my results very fast. So I was really interested to be the next helper for other researchers or PhDs and whoever academia and research are, needing this job and help. So very also happy to be in this workshop to learn more how to be a good facilitator and a better facilitator, and also to share my experience so far. Thank you. Did everybody go, or Sarah? Did Sarah go? Sarah?
Hi, I'm Sarah Stevens, pronouns she, her, hers, and I'm the director of the Data Science Hub at the University of Wisconsin-Madison. I've been in the Data Science Hub for 6 years now, and we help researchers across campus here learn and apply data science and research software computing techniques to their own research. I'm a microbiologist by training, so I learned a lot of these skills on the fly when I was doing my PhD, and ended up helping a lot of others while I was doing my PhD. That was mostly what I did when I was not working on my own thesis. And so that's how I ended up in this job, is that I was helping others so much that I found a job that let me continue doing that. And now I help researchers across campus. Oh, next up is Georgia.
Hi, I'm Georgia Stewart. I am a computational mathematician. That's what my doctorate's in. And like Sarah, I got into this work during my PhD when I became the kind of the person that the other students asked when they needed to use our HPC system. There seems to be one person in every department like that. So I got my PhD in computational math, did a postdoc at University of Texas, and then moved into facilitation after that. And now I'm at University of Massachusetts Amherst.
Great. So that completes everybody. So just to get us started, a quick question for everybody. Anybody can answer. But yeah, so how do you, when you get a new tool from a researcher that asks you how to use it, how do you approach it, right? You've never seen this tool before. Just walk us through your process. How do you study said tool? And I hope from there, the public will take on the questions after. But yeah, anybody's up.
I guess my first question is, what are we defining as a tool? Is it a piece of software? Is it a particular piece of hardware? Like, how do we want to approach this? So, um,
Up to you, really, just a general, let's say software just for sakes, because most of us tend to approach research facilitators that way, but I know it's different for some of us. So whatever works in your stream, what do you encounter more often?
most of the time, in my experience, we deal with software requests. Usually, we use a ticketing system. So somebody submits a ticket and asks, "Hey, I would like this piece of software installed for my research." So usually, the first step is to vet the software, whether that is due to its availability on the internet, its licensing, and then usually after figuring out the licensing, most of the time it's open source, but there are exceptions. Um, you figure out, well, how do I build it? And then I don't really go into details on all those things until I respond back to the researcher, basically saying, "Hey, yes or no, I can do this or I can't do this, depending on the situation." And of course, there are instances where you'll get sent a piece of software that is runs on Windows only, and then you have to figure out how to have that conversation about, oh, this is probably not the best platform to run this on, and give you alternatives on how to deal with that. I could say more, but I'll let Sarah talk since hand raised.
I'll go ahead and give my answer. And I guess I don't run a computing service, so we don't have any like there is a high throughput computing system here and HPC as well at UW-Madison, but I'm not affiliated directly with them. And so researchers come to me with questions all the time about tools that I've never seen before. And I won't say all the time. Most of the time, they're coming with questions about common things like Python and R and Unix shell and Git and those kinds of things. But occasionally they come with something that's really specific to their domain. And I think that's where sometimes the generalist skills are really helpful. It's not necessarily about knowing the tool that they're doing super well. It's about being able to ask the right questions and search the right things and be able to find the information that they need to get to that next step in their research and figure out what's going on with, maybe they inherited a piece of software from one of their lab members and you're trying to help them figure out what it's actually doing, or help them with an error message that they've never seen before. And so I think sometimes those generalist skills of having experience working with multiple languages and having experience in troubleshooting things generally, can be really helpful. And it's not so much learning always, but sometimes being able to figure things out and help the researcher themselves learn it. Although I'll say when learning stuff, I often approach it by finding an expert to run a workshop on that topic, and then I get to learn it and then I can teach it.
So I interpreted this question a little bit differently, I think, from the side of we have a new computing, research computing resource, and we want to promote its use to our researchers rather than them bringing us a piece of software that they already know they want to use. And how I approach learning that and figuring out where it fits in our researchers' software stack is just approaching it from the ground up, essentially. First, I always make sure I want to understand how it's going to fit into the bigger picture of what our researchers are doing. Like, for example, if it's a new storage workflow or something like that. Like we set up last year, HPC Workspace to handle our Scratch space allocations. So I would start by understanding, okay, where is this going to fit into most researchers' workflows? And for that example, it's largely used for workflows that require Scratch space where it is not persistent, because HPC Workspace will delete Scratch space periodically and clean it up. So it's not some place that your researchers can just stash data persistently. And that also involves understanding like what researchers on the cluster might have workflows that support that. And for us, that is a lot of genomics work. Those workflows tend to create large intermediate files that get cleaned up afterwards. They don't need to keep them long term. So once I understand who is going to get the most use out of it, then I understand and make sure I understand the mechanics by almost always setting up like a toy problem for myself to actually do the workflow and understand how it's going to work with like batch scripts or interactive jobs or whatever. So always implementing a small version of what I would expect a researcher to do myself, because that's when you really run into the edges of your understanding and eliminate the gaps in how you think it works versus how it actually works. And there's always a difference there. And then to teach it to our researchers, we have a documentation website that we add a lot of different aspects of our cluster to, and then we will also run periodic workshops on like new features or add it to our onboarding, stuff like that. And then for specific pieces of software that are not general interest, then we don't have a huge cluster. We have about 400, 500 research groups on it. So we have a pretty good idea of who's doing what, and we can reach out to specific groups to advertise our new feature or whatever.
And going off that point of documentation there, we just got a question on the chat. Like, how important is documentation for you when you're installing software helping out? Do you write your own or do you source it out? This is just open-ended. This is going off the having a documentation website, which I know is a common experience for a lot of us. Yes, Eric, go ahead.
Sorry, I don't know if I like the raising hands convention. Anyway, I would say it's the most important. Like out of all the things that we do as the RCF team, it might be the most important. People don't always read it, but you can always point them at it. We do a mix of writing our own and linking out to software providers. So like we try to document all of the software we have installed. There's a set that we maintain and provide generally. And so we try to have every page or in our module files, there's a help command that will print out similar things, that we have a working example, a basic working example, and then if they need more, they can go to the actual software website if that exists, or the user community. but having sort of piggybacking on the last question, as part of that learning process, taking notes during that whole process and turning that into the documentation is one of the most critical things that I found to be useful in poking at something new. Sorry, I know I rewound there.
And I just want to second the statement that they may not always read the documentation, but you can always point them to it. Um, I don't do a perfect job of this, of course, but we try not to rewrite the same ticket response multiple times. So if we find that users are coming to us with a similar question, we try to get into the documentation as quickly as possible. And to facilitate that, our documentation is just a static site that we generate through a Git repository, and we're constantly throwing things and issues of documentation that we want to write.
Yeah, and to add to that, whenever we add new users, we get new users added to our clusters. The first thing I do after I provision them is I actually just send them a link to a new user kind of start guide in the documentation. So one, they know where to get started, and two, they know that documentation exists. So it's kind of a win-win doing that. And also in my experience, I don't know if everyone else has this experience, but I feel like it's a double-edged sword. But sometimes you get new users within the same research group, and then they start piggybacking and handing off old job scripts, and that could be a bad thing. but usually they'll be able to get started because of that. But then you find out that you have like 20 users that have all the same problem with the same job scripts.
Yeah, Kefi, I saw you raise your hand there. If you have something there for this question.
Oh, thank you. So I support everything that was said, and I want to add that documentation a lot of times saves us a lot of time with the clients, especially when you have like everybody mentioned here, you have a group and you have new users from that group who did not have any transfer knowledge in that group, and then they came to us with similar questions. So referring them to the documentation of the software that we already have that has been extensively used with that group, saves us time and saves them also a lot of back and forth questions. Also, updating documentation is very important, but there are also some small times where we ended up having to schedule consultation or one-to-one Zoom meeting if needed, when things gets a little bit more in details that the user needs more explanations and the documentation might not be clear enough for them. So yeah, so it's a kind of a back and forth procedure, but documentation is always a big help to our team.
Yeah, so talking about content documentation, how do you keep track of it? I know we've mentioned a lot about producing it, but I know a lot of us deal with a lot of versions of specific files. How do you keep track of for example, a version of a program and updating to that? How do you update your documentation process?
Man, you really had to go there.
Well, I guess my answer is a non-answer to this, but we try not to document in our internal documentation specific versions of user-facing software. So our documentation is largely for how do you use an HPC system, how to use our HPC system. But if somebody wants to use GrowMax or the OpenFOAM or whatever, um, there is like a division of responsibility where they also have to, put in the effort to understand their software, and then we can help them use it on our system. But we're not going to document how do you use OpenFOAM, except for, the cases where OpenFOAM doesn't really like some of the ways that HPC clusters are set up.
Yeah, Nick. Right.
Uh-oh, we lost your sound, Nick. I hear like a little whisper, but can't hear you now.
No, we kind of lost you there, Nick.
check your,
Now, is that better?
yeah,
It's all good. Yeah.
Okay.
yeah.
Yeah, so we use Sphinx slash read the docs for our documentation, just so if we do make changes to a documentation, we can keep it up to date, but also sometimes we're able to look back at old things using that. We don't have application specific documentation yet, but that's mostly having time to write it. But but yeah, I think depending on your institution, some institutions may be strict on where you can place documentation, and I feel like that could be a challenge if you're looking for version control, for example.
Yes, we used to have a static site that was generated with mkdocs and markdown, and it was all in Git. It was great. We have moved to ServiceNow as our documentation platform over the course of a year and a half, maybe more. It was an enormous effort. And now version control of our documentation is a real problem. It's not version control in the traditional sense, right? But in the knowing what's outdated and what needs to be updated and managing it it's a completely different mechanism, and it's hard. We're still working. We're still figuring it out. I wish I could share our documentation site, but it's also partly behind login barriers now because of security policies that came down. So it's difficult. Michael?
Yeah. Mike? What?
Yeah, I just wanted to second kind of what Nicholas and Georgia said there about having general user documentation. That's something we do for frequent things like Globus and Python and R. But I think when you have really specific software, that's something you kind of have to address on a user by user basis and set up kind of one-on-one or more individualized meetings.
I can't figure out how to raise my hand, so I'm just going to keep busting in. But yeah, especially when you get when you're a part of a larger cluster with a lot of different fields, it just becomes untenable for your team to handle understanding every piece of software users want to use. So it's a better use of our time we feel to do like general purpose documentation and then help with specific software problems as they arise.
Yeah. And on that point, Georgia, just a quick question that popped up in the chat. How do you manage the needs at your institution? Like, how do you know where to dedicate time?
Oh, that's a tricky question. So at the Unity cluster, which is what I facilitate for, we have University of Massachusetts Amherst, but we also have three other UMass campuses and University of Rhode Island and two liberal arts colleges that are part of our cluster. So we're dealing with not only different departments within the same campus, but we're dealing with different campuses, and they all have different departments and different research focuses. So figuring out where to spend our time is a pretty critical question. To alleviate some of that, we have a multi-institutional team. So I deal with kind of the overall team. I'm the lead facilitator, but we have facilitators that help from University of Rhode Island and UMass Dartmouth in particular. And then we also have been hiring PhD students that are in specific subject areas. So we have a large bioinformatics and genomics need out of our population, which we have discovered over time. So to try to increase the amount of support available to that population, we've hired PhD student facilitators specifically to help with bioinformatics and genomics workloads. We also have a pretty significant number of GPUs on our cluster. We have about 1,500. So we get a lot of GPU users too. And admittedly, GPUs are not my forte. I come from, CPU, parallelized MPI wave modeling world, not from GPUs. So we have facilitators that are, or at least we have two facilitators now, one full-time from UMass Dartmouth and one PhD student from UMass Amherst that are primarily tasked with learning the ever-evolving GPU research computing landscape and supporting users on those. So I guess the short answer is divide and conquer. If you have the staff in order to specialize, then doing so I think is a good idea. But of course, that relies on having the amount of staff you need to specialize. So that's not always an option.
Yeah, on that same point for anybody else that wants to contribute to that question, how do you say no to a researcher and their and how do you teach them to maybe do it on their own? Where do you direct them to for further learning on their side?
To kind of echo what Georgia was saying, so my background also, when I was doing research computing myself, it was like mostly CPU, never using GPUs. But of course, everyone is talking about AI and machine learning and the using GPUs for research. And so you get a lot of questions about it. And for me personally, when I get students or researchers asking about this stuff, I usually am just brutally honest and be like, I am not an expert in this, but we can step through, we can struggle through this together. I can meet with you on a weekly basis because a lot of times, a lot of these researchers just don't have anyone to talk to about it. And I feel like as a facilitator, I'm sometimes that person that they need. So so usually in those situations where I'm not an expert on it, I still try to be supportive in the best ways that I can. So
Yeah, we have a similar approach that we will say no to installing particular software in our central stack if there are not enough users, not enough lab groups or researchers using it. But we will help people do local installations and do as much as we can, although our time is limited and there's only so many of us. So it's a challenge. If it becomes too much of a task, we have the option of telling people they need to start paying us for consulting time if they want to continue getting help, which very rarely happens.
Anybody else on that one? Not. Oh yeah, Kefi, I can see your hand there. Right.
Um, Thank you, Jose. So yeah, we have the same case. So if the user already have a privilege and can install the software, so by default, we always ask them to do it if they have enough privilege to do it locally in their folder. So that will be the first, way to install. Otherwise, if for any reason we have like mostly security reasons and safety of our cluster, like the software is not secure enough to let their users play around with it and access all these links that are unsafe. So it's our duty to handle that. And then personally, for my case, I would always consult with my senior colleagues, try to work that out together, see if it's out of my expertise, uh, see their advices. I mean, of course, if they can, if they have time, can do it quickly, that would be great. Otherwise, I'm here also to learn, and help, our, clients fulfill their, tasks as soon as possible. And as I mentioned, like most of the cases, we say no if the user can really do it and has enough privilege to do that. So that's like, I think, the way, like the rules. I so far didn't have any problems, saying no, because all the users already got familiar with that. Yeah, thank you.
Yeah, so just to address that question, Chris, when you refer to complex computing concepts, what are you denominating as complex here for our, in case you can answer that, just so we have a better idea there. You can text that in the chat if need be. Yeah.
can I take a swing at it with my interpretation of the question?
Go ahead. Yeah, for sure.
So I guess one example I think of is um So I don't know everyone else's experience, but I think one of the things that I think most researchers who start using HPC or any sort of advanced research computing infrastructure is that usually they have a strong domain knowledge on what they're using. They probably even have knowledge on the software they're using. The issue is using the actual system and that floor of being able to just log into a system using SSH, going through the command line, setting up the job script, running the job script, knowing where the data goes, pulling the data down, like all these kind of things that you learn from, let's say, the software carpentries. Those are the skills that they lack typically, at least in my experience. So usually when I'm helping researchers, I don't really run into dealing with the more complex or intermediate computing concepts. The only exception being is people who are using Slurm and have to teaching them the difference between a task and a CPU with Slurm because hot take, I think the names are terrible with Slurm, but that's just me. Uh, but that's probably the one I run into the most. And then when I do run workshops for those concepts, so typically I run a workshop about twice a semester, one where it's a beginner HPC conceptual thing, and another one is usually in advanced topics. I try to cover those things in that workshop because I feel like those are the things that do come up that is I would consider to be more intermediate. But uh, that's that's how I interpret the question, but feel free anyone else to jump in.
Yeah, to second what Nicholas said there, I think we've had the most success running kind of live workshops, either in person or on Zoom, doing kind of a tutorial, walking through the basics of logging into the system, creating an S-batch script, and basically just walking through even just like a simple Python program and letting users run it themselves on the actual system, so they get familiar with it, the process. That's what we found to be the most successful.
I will second that. I think a lot of it comes down to getting people hands-on on the system, having some sort of example that they can work through in a guided fashion, is most helpful from where we're coming from as RCFs. We're not doing a lot of conceptual teaching though, so it's not like we're doing real education on how, like, the math behind any of the interesting parallel computing problems or anything. That's more in the College of Computing and the things that they're doing. Having it hands-on, in my advisor used to say, have us, talk about practicing things until it was in your blood, and it's kind of that same level of, it's not you're not doing practice problems, but it's getting the muscle memory started and having a feel for what it's like in the actual environment that you'll be working in. That's been most helpful for us, and in like workshops that we've run, like trying to teach people how to optimize their code. We give them a bad example of code and we have them work through benchmarking and profiling and optimizing it very simply without forcing them to write code in a 2-hour workshop. That's a disaster. And it seems to be helpful. It introduces people to the tools and gets them started to be able to use it on their own. Georgia?
Yeah, I put this in the chat, but just to say it verbally for the recording. But I find people have said previously that we don't teach a lot of like computing concepts. We do occasionally like subject area workshops on like a workflow tool like SnakeMake was one that one of my students put on last year. But I teach a lot of what I would consider problem solving and debugging skills. That's, I think, the primarily what we actually end up teaching when we're helping a student debug or learn how to use the cluster is how do you even approach a computing problem and get through it and understand how to figure out what you need to do next in order to figure out what's going wrong. And in terms of that, since I come from the math world, I like to go to Polya's problem solving framework from how to solve it. And the thing that I probably reach for most out of that book is the solve a simpler problem first concept. So every time a student comes to me with like something that's throwing errors and they don't understand what's happening or like where the problem's originating from, I help them like step back and make the simplest thing that replicates the error first. And that's usually much easier to figure out what's going wrong than trying to, look at their full pipeline or whatever.
Yeah. Anyone else with that one? Let's react to that. Oh, good. I think we got all questions currently in the chat. Last one would be like how much one just came through. Okay. So how much do you feel you've learned about the various research fields that you help out? Right. So we end up interacting with a lot of different ones. How do you think that's helped you out as a facilitator when going in future projects?
I feel like I'm the person who has something to say about everything during this call, so sorry for monopolizing. But I the reason I love this job is because I get to learn something new every single day. So I love to be approached by a researcher in a field that I know nothing about because it's just so fun and satisfying to dig into a new field and start to put together the pieces and connect it back to what I already know. So I think a lot of this is because I am, I did my schooling in math, and everything in computing is math at its core, essentially. That's debatable, I'm sure. But being able to look at a new field and then connect it back to what I already know and then extend what I already know is the best part of the job. And then that also makes it easier to jump to the next problem that extends that part of what I know. So it's all, you can't be a good facilitator without learning from the people that you're facilitating.
Plus one on Georgia's answer generally. I think it's really fun to learn from the new fields. I mean, I'm a microbiologist. I love seeing microbiology, genomics problems, but at the same time, some of my favorite projects have been like from linguists and other areas that are totally unrelated to mine. It's fun to get to learn a little bit about their work. And that helps you make connections with future things. I had another linguist come who has very similar data to a linguist that I had worked with a few years ago. And I, had some idea of some of the values and could kind of understand what kind of data he was looking at when I met with him. That was really helpful. But also, like some of my favorite things to teach are really things that I didn't know when I started this job. I remember we piloted like the data carpentry genomics, or sorry, geospatial workshop. My first year here in this job, and I didn't know anything about geospatial data. And it's one of my favorite things to teach now because I really love the interesting and complexity of that data type that I'd never seen before when I was working on it. So one of the things I'll also mention about learning different areas, specifically because this question talked about the communication part. And I've noticed that researchers communicate data in different ways. In particular, working with humanists, I've found they don't always think of what they're working with as data. They have a corpus or they have other, they call it things that I would think of as data. And so kind of learning how people use these terms and how to connect with them on the terms that they find familiar and how they're using them is really helpful in like making that connection with the different researchers in different areas.
Go ahead, Eric.
Oh no, I'm sorry, I lost my train of thought a little bit there when I was clicking the raise hand button.
Okay.
But yeah, the picking up the jargon from different fields is so important to be able to get to understand where a researcher is coming from. I feel like I haven't learned as much as I want to, which is there's so much. It's so great when you actually do get time with a researcher to understand the problems that they're working on. I think it's one of the things that makes this a fun space to be in. it's definitely there's always something new to learn every day, which is great. And communication is sort of the getting better at that is the piece that um, sort of become indispensable, which is why I put documentation first on my list. Everything we do is about communication. Sorry, I went really big there.
Yeah, and talking about communication, when a researcher approaches you the first time, how can you gauge what they already know, right? So we're not repeating what we were teaching. How do you approach that first interaction?
I think part of it is you have to be clear that that you do have to ask some questions, and you need to make it clear to them that you're trying to understand where they're at, um, as much as possible. Learning, being able to listen and comparing it to other people who've come in and picking up on which pieces of jargon are they using, how familiar are they with the system is very helpful. But just being honest, say, hey, I need to make sure I know where you're at before we start getting too deep. I'm going to ask you some questions. It's okay if I'm not trying to offend you. I just need to be sure what you know and what you've done.
I have that like motion one, and it doesn't work half the time. So
Oh, the Apple thing, yeah.
the raise the hand thing, it doesn't work half the time. So most of the time, my initial interaction with a researcher in most cases is through an issue or a troubleshooting thing. So we'll jump on Zoom or Teams or something most likely, and I guess I get a gauge on their expertise on using the system based on just that initial interaction. Because usually I will ask them, hey, log into the system, change directories, look at the files that are in this directory or show me where the files are. And based on that interaction, I can get a good first impression on where they're at. And then depending on where they're at, I will, of course, adjust based on their skill level. So in some cases, they're not very comfortable with the system. So we'll have to, slow down and I'll have to explain, what commands to use. I may give them tips along the way, like, oh, did you know you could use tab to complete that command so you don't have to type it all out? That sort of stuff. So usually those first impressions are usually where I gauge where they're at. And then when I run workshops, I usually try to make them take a survey when they register. So the registration is the survey. Um, so then people can kind of assess, on their own opinion where they're at before they go to an intro workshop. So at least I have a sense on where people are at when they come in, at least on a distribution. So
Also,
Yeah.
George and Sarah, I know you answered that question in the chat, but is there anything you would want to add here? Yeah. Yeah.
Yeah, I'll just add that like Nicholas said, you can usually tell from how a researcher interacts with like the command line or describes their problem to you if you probe for like just further open-ended questions what their comfort level is. So you don't have to like ask direct questions like, do you know how to change a directory? You can just see that based on what they're showing you the problem is. So you don't have to, it is tricky because you don't want to assume that they know less than they do. And like, I don't think I've ever had anybody actually get offended, but you don't want to make them feel like, okay, we're going to step back to a really basic level and start from there. But one tactic I like is just asking them to explain what's going on in the way that that you're prompting them to help you understand. Like, can you help me understand what this problem is and when it's occurring, stuff like that. And I like to phrase it in that way, where it's like they're helping me to understand what their problem is and what they need out of it. And I find that that is pretty successful in getting people to be forthcoming and comfortable in the debugging process. And one more thing to add to that is just don't assume that you know what the problem is from the initial point of contact. That's something that I have seen people do is they'll jump into debugging directly without making sure that you are understanding what the researcher actually needs and where things are going wrong and what the breakdown is beforehand. Because it's often something that is related to what they're doing, but not quite exactly what they're telling you to start with.
Yeah, and now talking about like education and how we approach that, do you do you offer any talks for researchers on your system to talk about what they do to your system, or is it more like a one-ended conversation with workshops? You provide the way for them to give the feedback back, and how successful has that been?
I'll be honest, this is something we're working on. Getting that two-way communication because a few months ago I started just trying to find out who has done research on our systems and has put it in their publications. Like, how can I find that information? And it just took a lot of Google searching, but I feel like if anyone else on the panel has experience doing this better than that, that probably would add to the answer to this question. But one idea that our group has had is to start creating, meetings between departments and hopefully doing presentations where we kind of present us as a group to start that conversation because there are still researchers at our university that they probably don't even know we exist, and are using other resources. And then having that conversation open up in a way where you can follow up in the next semester and be like, oh, hey, like we see that we have these people in your department using HPC to do your research. Can we set up like a little symposium where, students talk for 10 minutes each and just say what they worked on? But that's an idea we've had, but it hasn't been executed. So
Yeah, Sean, I see you have a question there. You want to share with us?
Yeah, hi, great panel. Nicholas, just kind of to go on what you were just saying, what we did at Wake was we worked with our library and we got a DOI. It was actually the first DOI minted at Wake for our cluster. And so we would provide a citation that had the DOI, and then when people would use the cluster, they would reference the cluster using the DOI, and then we were able to get bibliometrics based on that. So if your university has the capability of minting DOIs, that can be a really kind of quick way to get that accomplished and save you some Google search.
thank you. That's a great idea. I will investigate that.
Yeah. Georgia, go ahead. Yeah.
Eric, was your input on the bibliometrics train of thought? Because if so, you can go first.
It was
Because
it was
I'm going to go on
on the
different
same.
tangent.
Okay, yeah, no, it was on the same thing. Thank you for asking. Yeah, we actually had a similar project that eventually failed, but your grants and contracts office will probably have some very useful data from you if you're able to get it out from them. That was where our effort fell over, but we were trying to work with them to get data that we could cross-reference with our XD mod using a tool that is no longer supported, to get publication data and see that sort of thing. So it's a noble effort, and I wish you well. I'm done.
Going back to the original question where organizing ways to get notes on what people are doing on your cluster. So we haven't had like a formal talk series. It is of interest, but I've also, since we are like 6 different universities at this point on the cluster, everything would have to be online. And I get the impression that people are a little burnt out on like online symposia coming out of COVID. So I don't know if that would be a great use for our time, though there are so many people here, so that's amazing. Henry did a great job organizing. But one thing that we're doing is Slack groups within our support Slack. So the Slack is not for everybody. It is a pretty big lift to have an active support Slack, and we do spend quite a bit of personal time managing it. But within our support Slack, we have channels for like bioinformatics or AI/ML, which are places that we try to encourage discussion between researchers from different institutions that are in the same or in related fields. And we try to foster uh, collaboration and conversation between them. So we get some informal data on what people are doing there. And then we've also seen some fun conversations go by. It is something that we want to spend more like a more intentional time fostering this next academic year, but it's been pretty successful so far to get that going, and it's a little bit more fluid than a talk series.
Yeah, to second what Georgia said there about in-person workshops versus Zooms, that's something we've done with our multiple institutions on the cluster. We've actually had some of our sysadmins travel to different universities in our state to give talks and workshops in person to different students and researchers at those institutions. That's been really successful, plus the Zoom workshops.
To add, in addition to the feedback we get like through feedback mechanisms like surveys on our workshops and etc. Sometimes it's observation that we're able to kind of learn about from like consultations, observation of what people are asking questions about. We kind of get feedback through the observation that facilitators are having themselves. But also one of our other activities is hosting communities of practice. So we have like a machine learning community of practice, a computational biology community of practice, and we have various activities of those communities of practice. And that kind of helps us start to figure out where a lot of the questions are, where people are getting stuck, and what's going on in those various different areas as well that we could help support.
Go ahead, Kev.
Okay, thank you, Jose. So we also have something that we started in our team, which is we are trying to dedicate some of our facilitators to specialize and be like first contact for certain departments and keep the conversation and the contact and the communication with that, group in that department. And then that helped in a way to increase the communication and have better feedbacks. And when we try to send surveys to ask them like what is their interest, or surveys sometimes they are answered, sometimes not. But having like more close and private communication with the different departments and groups helped in a way to collect, for example, if they have been doing any publication in that, using our resources, or also helped, during sometimes any consultations that happen with that department, and through, of course, one of our facilitator who is dedicated to work with them, who has been, helping them, installing software, debugging, doing all the work. So the team opened up, and then they were more comfortable sharing and finding more time, to let us know about their interest, their research, how we helped them, like how our resources were helpful. So that was one thing, because obviously what we all have been talking about, figuring out the research interest and how the research was helped by our resources has been like a big debate in our team too. Thank you.
Yeah, so I see a conversation in the chat. I just wanted to bring it out here, talking about with Sarah particularly, how do you create a community of practice? I know Georgia mentioned like having that Slack support, but talking about other ways to do it. How just mention them there.
our approach usually with starting communities of practice is putting together a town hall meeting about whatever topic we think people are interested in. Sometimes that's actually starting out with talking to the people who we know are interested in that topic and seeing what they want to bring up at the town hall, and then using that to seed a discussion at the town hall about what are the needs in that area. In fact, the data science hub that we run now was started as a town hall meeting where we met with researchers across campus and we said, what are your needs around data science? And asked specific questions. And then we came to realize that we needed specifically data science facilitation. And that's how my team started. But we do the same thing when we host our communities of practice as well. We usually start with kind of a town hall. This is a topic that we think that there's a need for research or for communities of practice around, and then talk about what they're interested in. With every year, we actually kind of do that at the beginning again of the computational biology community of practice I run. We have a Python in our study group that run as part of those, and that each semester we meet and we say, hey, what do we want to learn about Python in our this semester? And so kind of listening and figuring out what the needs are. Sometimes that's, okay, we need a Slack workspace. The genomics community I work with a lot wanted to have a Slack workspace specifically for genomics. And so we were like, hey, we have a Slack workspace already. You can have a channel in here and we'll help facilitate that. And they already have their own annual retreat and other things, but they wanted help facilitating that and having somebody who could help answer kind of technical questions in that space. But other ones, the ML community of practice, we have a monthly forum during the semester where people share some of their applications of ML across different research domains. And then we have an ML plus coffee event where people meet up and they talk over coffee more informally. And they've also started running a hackathon as part of that community of practice where people work on Kaggle projects. And so it really varies based on what the interests of the community are. But I think having a facilitator lead those communities and kind of be a part of it is still really helpful for making sure that there's momentum and support for those communities when they need them. Because things run by the researchers themselves, sometimes they have trouble booking rooms and regularly remembering to schedule things and stuff like that, where that's part of what we do as the facilitator for those groups.
And to
Thank
add
you.
what Sarah said, having facilitation presence there also helps to just make our presence more widely known and put friendly faces on the HPC team, which is always nice. So just being present in those communities of practice, which is what we're trying to build, but have not been as successful yet, and having the active support Slack lets our facilitators be very visible and very known in our user community, which I think helps a lot. So we're not just somebody who answers your tickets via email. We're people that you can chat with. It's like either about a problem that you're having or about some cool research computing thing that you've read about and just wanted to talk about with somebody. So I think that's a side benefit, but is also a very valuable one.
Yeah, so shifting gears a little bit there. I know there's been a thread on the chat about what is the most common error you've seen. I think this is definitely going to be a venting kind of question, so go ahead.
I'll just reiterate what I said in the response, but the most common mistake I see typically is not understanding the difference between what a task is and what a CPU is in Slurm. This is really common with a lot of Python applications because due to the global interpreter lock on Python, it can only use one process without, doing something else basically. And a lot of like NumPy and SciPy routines are actually written in C, so they can use multiple threads. So when they're using those applications, usually the workaround is to just throw more CPUs on the same task. So you'll get these like new researchers who are just throwing tasks at a problem, and it turns out that they're just running the same application, multiple copies of it with one thread per task. So that's the most common one I see personally. But I'll let other people jump in.
Yeah, I'll share. That is a good one. We actually had to correct our documentation a while ago because we realized that our basic Python example was doing the wrong thing. And like that's why this keeps happening. And we did, and it stopped happening as much, which was great. But also people do read the docs even if you don't know about it. Um, but the storage one is really what has been our biggest thing that harms the system because well we've had a lot of storage outages in the last year and a half, and I don't want to say it's not always like it's not user error because it's how can they know what the right thing is to do without the deep experience of here's how you work with Lustre nicely. And it's people it's that's not something we've tried to tackle in our documentation because it's very complex and sometimes it's something that we need to fix on our end. But when you have people doing thousands of read writes across hundreds of nodes, it's a recipe for danger.
And for those specific problems, how do you handle teaching to those users? Do you try to schedule a workshop with all the users committing a similar mistake, or do you try to address each one on one? Just want to figure
We
out.
it's usually typically it only takes like a handful of people to send things over the edge, right? Because they have the power of all these compute nodes. So it's usually very one-on-one. We'll notice, hey, this person's causing a really high load on our metadata servers. Let's talk to them and figure out what they're doing and help them do it in a more file system friendly way. Sometimes they're working on the wrong file system. Sometimes it's okay, let's restructure this so you're not doing thousands of things in one directory, or we can split this across different nodes more effectively. You can use local storage instead of parallel network storage. Um, it's very, very situation dependent. Amira?
Yeah, thank you, Eric. So, based on my small experience so far, like the most common error, especially for new users, is the difference between login nodes and compute nodes, especially when coming, trying to run their first job or trying to find the modules or load modules, So we even have been discussing, okay, maybe we need some, messages when they log in to tell them, hey, this is login node, please, whatever, like do your job or your module loading on compute node. So yeah, that's some of these, common errors, but just for new users. Otherwise, like, after a while, everybody's fine. All the errors are equally proportionally distributed.
Yeah, the login node versus compute node one is a problem. And as NM says in chat, we have CPU throttling on our login nodes so they don't fall over as often as they would if we didn't have that. So that helps. And then we also add a message in the MOTD that pops up when you log in via SSH, but I would be surprised if more than 10% of people read that. But Open on Demand has actually been the biggest help with avoiding this problem because so many of our new users that aren't in fields that want to run like long running batch jobs or MPI jobs or whatever, they're interacting with our cluster through Open on Demand where this isn't a problem. So that's been a big help in avoiding some of the what would be like a very intimidating error for a new user is they have a nice graphical friendly way to use the compute resources they need without having to make all these mistakes that we have all made and that pretty much every new user makes on the cluster. So shout out to Open on Demand for making everything easier for everybody.
Yeah. On that same line of making mistakes, can you guide us through some mistake that you made while teaching somebody a resource and how you solved it later on?
So there was a point in my life when I was trying to teach a bunch of people how to build virtual clusters in the Jetstream cloud. Um, using some tools that we developed as part of Access. So it was not quite RCF work, but it was a hands-on workshop. And I had the bright idea to go rogue and do things that were not written down and try to get people to follow along. And it was just the worst disaster that I've ever done in a teaching environment. I immediately lost everybody, had to rewind and sort of switch over to more of a talking mode versus having people do things hands-on, because there were some things on the back end that weren't working like they were supposed to, and it was a painful lesson in running live work effectively. Don't go off script. Don't go off script. Be very careful when you do go off script eventually. Make sure people can actually see what you're doing and follow along.
I have a similar anecdote to you when I was running a workshop on intro to MPI using Python. I had a simple example where it was just matrix vector multiplication using multiple processors. And I was like, okay, well, as an exercise, let's use gather v instead, or it's gather instead. But then at the time of doing it on the fly, because I just thought of it in the moment, I spent like 45 minutes writing the adaptive version. It ended up working out, but it took longer than it should have because I was not prepared for it. So yeah, teaching in front of people when you do things on the fly, you're already getting tunnel vision and you miss things already, and then add some improv. Yeah, not a great combo.
Yeah, piggybacking off that for live demos, anticipating things that even if you went through it individually by yourself, having 30 or 40 people doing it all together on the login node may not always work out well, or having them schedule GPU processes when you have less GPUs available than the number of users in the workshop can cause a lot of delays and frustration there. So anticipating those sort of things during live demos, something to think about in the future, something to learn from.
Yeah, on the resource contention for workshops, I've learned to always make a reservation if I want people to do something live on the cluster. Never rely on the queue behaving that day. And then my mistake is not really like a teaching, a workshop related, but in my first job as a facilitator at my alma mater, UT Dallas, I learned the hard way that MATLAB will check out a new license for every core requested. And I learned this by helping a user set up a pipeline wherein they ran like 2,000 MATLAB cores at once. And it DOSed our MATLAB license server for the whole campus and brought it down over a weekend. So that was fun. I was not liked in central IT that weekend.
So yeah, I think this is gonna be the last question here before like wrapping up statements for all of y'all. But does anyone have any resources? I assume it's learning or teaching resources for HPC admins, particularly. I know Eric, you work a lot with sysadmins, so let me throw this one to you first. For anybody
You
else,
caught
ideas.
you caught me as I was typing. Very nice. The first thing that came to mind was the SIG HPC SysPros ACM Special Interest Group has a great Slack channel, and they're typically very friendly. The Beowulf list is still around if you are into that. Email lists. Campus Champions list can be a good resource, although that can get very policy heavy more than sysadmin heavy. There's a lot of folks on there with a lot of knowledge that are happy to share. What else? Those are my top three, I think.
Can you repeat that first one again? My bad.
Yes, it's a big acronym. It's called SIG-HPC SysPros, and I'll write that down in chat as well. short for HPC System Professionals. It's an ACM interest group, and I think it's very open. They do have if you want to join and be a member, it's like $5, which is cheap for one of the ACM groups. But I think those are my top three. I haven't thought of anywhere else in the meantime that's active. There's the CARC resources. So the CARC has a systems facing network as well. It has a semi-active mailing list, I think, and they have regular meetings. Also, the Open HPC project has a lively mailing list and regular meetings. And now I'm done for real. Sorry.
So you're good. Yeah, so
I
now that
also
we have last hello.
I also dropped the link to another SIG HPC chapter, the education chapter, which is very related to what we've been talking about. So that's a chapter like SysPros, but for education.
Yeah, so now that we have these last 5 minutes, I would just encourage panelists to say a little line or two about learning and teaching. If you have some last tidbits or tips on how to do it well that come to mind now from all we've talked about, yeah, that may serve our beginning facilitators well. Go ahead, Sarah.
Join the carpentries. I may be biased. I'm actually on the board of the carpentries because I've just bought fully into the model of the carpentries. I really like open source education. So I really think putting things out there that we can work on together and make more robust is really helpful. But also the carpentries has created instructor training to make help you become a better instructor. And we recently developed collaborative lesson development training. So it helps you make open source lessons that are taught in a similar style as the carpentries, and you can put them in the carpentries incubator if you want and get other people teaching them. It's just a really great system for creating new lesson materials that help people learn computational skills. And so I highly recommend it. Reach out to me if you have questions. I'm always happy to talk about my experience and learning and teaching in the carpentries community.
Anybody else?
I'll go next. One thing that's helped me the most is I have a background in education. I got a K-12 teaching certification and I have a master's in ed. But having that background and just understanding a little bit about how people learn has helped a lot. So I'd recommend looking at something like the book How People Learn. It's a really good book and easy to remember title. And just getting a sense of the learning process. And what that does for me the most is helps me keep in mind the difference between experts and novices. Like I'm an expert in something, but I'm teaching to novices, and I have that meta understanding that how I view a problem is not going to be the same way that the way they do. So I do a lot of like trying to put myself in the shoes of what they understand, and I find that helpful. And it's connected to what Sarah was talking about with the carpentries too.
Yeah. Kathy, go ahead.
Yeah, thank you. So a lot of our workshops, we had a lot of feedback from our users when it comes, to the learning process and how we can improve through the different surveys that we made. We got like tips from them, like directly. For example, we improved, our workshops through some, video recordings that, short video recordings that users asked for different concepts that we try to do during the workshops. We also try to do different hands-on experience, and especially sometimes do like in person, not only virtual. So in persons workshops and meetings, they helped a lot through how they learn, and also we learn from them how much we can help and how much we can improve our help to our users. Yes. Thank you. Yeah, I'll pass it to Nicola. Nick?
Yeah, just a quick one. I would just say probably the biggest tip I would say is to don't be afraid to lean on your coworkers. And if you don't have many coworkers, people in this community for help. I feel like a lot of times I will spend hours on fixing, let's say, a build or some other issue to a system, and then I ask a friend, colleague a question, and they know the answer immediately. So don't feel like you're alone, because there are a lot of smart and helpful people in this community. So that's all I'll say.
Yeah. So given that it's 3:45, I want to wrap it up and give it back to Henry. But thank you so much for participating to the panelists. And thank you so much, you, the audience, for the questions. I hope some of this is helpful. And please check the big doc containing all the typing from today. There's a lot of typos on there, but I think we got a lot down and all the links there. But yeah, thank you so much, and I hope you have a great rest of your day.
Thank you, panel. So let's give these folks a round of virtual applause in the chat or with thumbs up. Thank you, Nicholas, for that demonstration. I'm going to go ahead and shut off the recording.